This is Alex Floor from Lab MO5 doing the first video diary for Lab 1, Constant Velocity Motion. We will be observing a tumbling person, and the main results of the video that we hope to get is that if Fnet equals 0, the model provides an accurate prediction for the observation of the model's motion using the fundamental principle, or the momentum principle, of Newton's second law. So here's the video of the tumbling person. As you can see, the origin is set at the person's foot and is slightly skewed to take into account the angle of the filmer and to keep the person tumbling along the x-axis. For calibrating the video, we used the person's forearm, and that gave us a calibration because for the video, and that was approximately 25.4 centimeters. Each of the red dots or data points that were collected were used as the person body made contact with the ground. So as you can see, they're tumbling, and this video is about 1/30 frames per second. And you can see the data is fairly linear, and all the data points are collected here. So we go over to Python, and we have our code in here, and what we hope to do is predict what the velocity would be, or the position of the person would be, knowing that we have the ball's initial position and the ball's initial velocity. So when we run this, we see that the ball moves at a positive or a constant forward velocity, and this matches the data. This information is not related to the direction of the person in the previous video. As you can see, they went to the left, and we set the origin for this video, the positive x-axis in the left direction. These two are not related. This video shows the ball moving forward at a positive direction, and this is represented in the graph. We then go over here and show all the data that was collected, and the mass of the person was approximately 68 kilograms, with the initial position being 0.54 on the x-axis, and the initial velocity being 0.6829. This number was gathered using this formula, delta V over delta T, and the approximate observation time, or the length of the video, was 1.467 seconds. Again, here's the same information, but just used to convert with units with it. So we then go and we had the data that was pulled from Tracker, and each of these data points represents one of those frames collected and is shown here. Then this line is the prediction for where the object would be, and as you can see, it's a fairly good prediction with a 0.996 r-squared value, and this is the equation of the line. Again, here's the initial velocity, initial position, assuming that Fnet does equal 0. So then we go to what if. What if we had chose the positive x-axis going to the right instead of the left as we had done? All this would have done is it would have changed the position to be a negative value and the velocity also to be a negative value, and this means the ball's motion would have been the same, but the x values would have gotten more negative as time goes on, and the graph would have been decreasing. So basically what this video means is that starting at a constant velocity, setting Fnet to 0 gives a very good fit for our data, and on the flip side of this, this suggests that if Fnet was not equal to 0, it is not going to move at a constant velocity. Changing Fnet to not equal 0, the model moves to the left, but it is no longer at a constant speed or direction.